We're going to deal with the terminology that we use in plant mineral nutrition. There are a lot of terms that we have to fully understand in order to be able to deal with mineral nutrition. But once we understand these, we'll find that everything repeats under these same terms. First, we're going to start off. What's an essential element in plant nutrition or any nutrition? Any element that is required by the plant in order to complete its life cycle. This is the first characteristic that we have. We've got something that is required by the plant in order to complete its life cycle. It's not superfluous. It's not something that could be there. It must be required by it in order to complete its life cycle. Second, it must be essential to the development of the plant, which means it's got to be an integral part of the plant tissue and how the plant works. We determine these two parts from growing the plant from seed in the absence of the element. If we cannot get it to complete its life cycle in the absence of the element, but it does complete its life cycle in the presence of the element, then we have an essential element. So it's a rather simple kind of process. This is going to be an essential element. We take the material, we grow it in the absence of it, we grow it in the presence of it, we check it under different amounts to find out whether or not something is essential. This seems rather straightforward. Some elements are required by a limited number of species. So some of the materials we will talk about, which may include things like nickel and silicon, we know that they are required by certain plants, but not by all of them. If it's required by a limited number of species, it can still be considered essential, even though many other species will not need it and it will not be essential for them. Let's look at classification. There are many different ways that we can classify these. We're going to look at a couple of different ways that are common classifications. One is based on function. You're actually looking at what it does within the plant. Based on that, you place these in different groups. We have those that form organic compounds of plant. We're not necessarily going to go into the carbon, the hydrogen, and the oxygen, which are the main makeup of everything. We will talk about them as nutrients. Those that form organic compounds of plants with the addition of nitrogen and sulfur that are used to make amino acids and other compounds, therefore are quite important. We have those that are part of energy storage or structural integrity. This includes phosphorus, boron, and silicon. Some of these may be more important than others. We know that phosphorus is very important. We will talk about these as well. We have those that are found in ionic form, which means they are doing something based on charge. These include potassium, sodium, magnesium, calcium, manganese, and chlorine. We have those that are involved in electron transfer, which include iron, copper, zinc, molybdenum, and nickel. These are based on the way that they function within the plant. This is one of the methods of classification. Another method by which we classify these is macronutrient, micronutrient. Macro means big, so you need a lot of it. Micro means little, so you need a small amount. A macronutrient is defined as an essential chemical that is found in concentrations greater than 1,000 milligrams per kilogram dry weight. This is approximately 1,000 parts per million. When we deal with these, we take the tissue of the plant, we analyze the tissue of the plant, we dry it down, take the water out first, because we want to have everything on a constant weight. We analyze the material on the inside of it. If what we find is greater than 1,000 parts per million, then we consider it to be a macronutrient. The macronutrients include nitrogen, phosphorus, potassium, calcium, magnesium, and sulfur. By the same token, we will have a micronutrient. A micronutrient, by definition, says it's an essential chemical that is found in concentrations of less than 100 milligrams per kilogram dry weight. Notice the difference between the two. One was 1,000 or more, this is 100 or less. This gives us a gap in the middle of between 100 and 1,000. This is a very clear-cut distinction in most plants where you're not going to find anything in middle ground. So it's not that we have to make a great decision. It's a very easy decision to make. Either it's over 1,000, it's under 100. When we look at a micronutrient, we're talking about iron, manganese, zinc, copper, boron, molybdenum, and chlorine. These are all required in very small amounts by plants. We're going to see some other things that I haven't included in here, which include things like silicon. Silicon is a very special one where it only looks like it's essential in certain plants. Very large distinction between micronutrient and macronutrient. It's extremely important to understand the difference between the two.